Supercharged Math. Today we are going to dive into the world of percents. How did you like the lesson last week? What did you guys think of the lesson that we had with percents and used in the real world with budget? Yeah, amazing, right? So percents are super powerful, and you guys have enough under your belt right now where you're comfortable with fractions and decimals, and we're going to start to wrap that together into the world of word problems, into the real world. And so that's what we're going to work on today. So pull out your pencil. There's no handout. Pull out your pencil, and we're going to get started with some problems. Okay, I'm going to move myself so I can write on the whole page here. Okay, so the first thing is a review. Imagine I have 120 M&Ms. And I tell you that 37 of the M&Ms are green. I want you to tell me what percent are green. Okay, wait, stop before you do the problem. If I said, not 120, but if this was 100, what percent are green? You could just pull it right out, right? If 100 M&Ms were on the table and 37 are green, it would be 37%, okay? But it's not 100, it's 120. Okay, so how do we do that? So what we want to do is, this is a review, so I'm walking you through it, okay? So the whole goes on the bottom, just like with fractions. The denominator is how much defines the whole, 120. The numerator is how many are we talking about? 37. And you all brought your calculators, right? If not, go grab it. You need a calculator for today, okay? So this is our fraction. We multiply it by 100 to get it into a percent form, okay? So take your calculator and do this with me. Actually type in the numbers with me, okay? Times 100. We now have 30, and let's just do one decimal point. 0.8% are green. Okay. All right, do you see how that's done? And again, if this was 100, then this would have been 100 on the bottom. 37 over 100 times 100 would have been 37%. But it's not 100. The whole is now 120. So you have to take that into account. You see how the problem changes? Good. So can you round this to the nearest whole number? Sure. This would be, so you'd go one click over from what you want. So round to the nearest whole number means to the ones. So you go one space to the right. If it's 5 or above, then this goes one higher. So this is 31% are green. Okay. Let's try another problem. Let's say you did some chores and you earned $6.50. Okay, doing chores. So earned doing chores. Okay, earned doing chores. Good. You spent $3.45 on something fun. What percent did you spend? What percent of how much you earned did you spend? Okay, so real world problem. We earn money, we spend money. That's something we're going to be doing pretty much forever. It's important to know, this was actually from a question from last week where we learned how do we figure out what percent of something a certain dollar amount was. Okay, so how much is the whole? Is it 345 or is it 650? Yeah, it's 650. Okay, good. So 650 goes on the bottom. And how much are we talking about? So I want to know what percent did I spend. So if I spent 650, it'd be on the top, and I spent the whole 100%. I spent the whole thing, but I didn't. I spent $3.45. Multiply it by 100. Okay, go ahead and use your calculator and tell me what you get. And round it to the nearest whole number. Round it to the nearest whole number. Okay, this is the part where you're telling me the answer now. Any calculator will work, yes. Any calculator you like. Okay, good. Okay, so here, I'll do it with you. 345 divided by 650 times 100. 53 point, no, a bunch of stuff. So this is approximately 53% So you spend a little more than half. A little more than half. How are we doing so far? Put the look on your face how you're feeling about this. We feeling okay? Good. Okay, let's try another one. Can I move this? We good? Okay, great. So let's say your favorite thing you wanted to buy, I'll just call it a toy, but it could be anything you want. Okay, a toy was $19.97. That was the full price. It's on sale for $12.97. Yay, same toy. So this is the regular price. Stuff goes on sale all the time. Question, what is the discount? How much did they discount the price? Is it half off? Is it 10% off? Is it 30% off? What is it? What is the price? What is the discount? So it was this for regular price. You found it for $12.97. Okay. How much are you saving? Like, what is the percent off? This problem can be done in a number of ways. You guys are getting old enough and experienced enough with math. There will be multiple ways, and as long as you're careful, you will get the same answer. Okay, so let's do it together. Do you want me to show you the long way, or do you want me to show you the shorter way? Which way? Give me a thumbs up for the shorter way, thumbs down for the longer way. Can you show me? What do you want? You don't care, I see both. Okay, all right, we'll do both. Okay, so let's do the short way first. What is the whole? The whole is the whole price, regular price, $19.97. Okay. So you have to look here because what you put on the top is going to change depending on what you're looking for. So I want to know what is the discount. So if I put this number here, what's going to pop out is how much of the whole price I'm paying. So I can do that. Oh, I should put multiplied by 100. Sorry, I forgot that. Wait, don't write that down. So times 100. So this number, you have to think about what it's going to give you. This is going to give me what percent of the entire price am I paying, and then you could subtract that from 100. So $12.97 divided by $19.97. So I'm going to round this number, 64.947. I'm going to round it to 65%. So I am paying 65% of the original price. So the original price is 100%. This is 65%. How much is the discount? You subtract these. The discount is 35. So it's 35% off. Okay. A lot of people want to just jump and start calculating. If that's you, know that you want to spend about 80% of your time setting up the problem down here. And because once you get the calculator in hands, I mean, it's easy to divide and add numbers. We know how to do that. And that's why I think people like to grab this. They're like, oh, then I'll feel like I'm doing something. Spend most of your time thinking about the problem and what you're going to do with this. Okay, so this was a two-step problem. This is step one. Step two is you have to figure out what the discount was. The other way to do it is to do the subtraction up front. So you'd subtract these two numbers, and then whatever you get from subtracting these two is what goes here, and that will give you 35%. So that's the other way to do it. Good. Okay, so how are we doing? Did you follow that one? That one? Okay, great. Where are my kids that love to read? Where are the ones that are readers? Yay, me too. I read, I think, a 400-page novel one time, all in one shot. Okay, so if I tell you I can read 40 pages, and it depends on the type of book, right? Some books you can really whip through, and others, man, it takes a long time, in 1 hour. Okay, I can read 40 pages in an hour. My new book I'm really excited about, my new, let's call it a novel, my new story is 318 pages long. How long is it going to take me? Okay, so with problems like this, I want you to, before you get lost in numbers, I want you to put your finger on things like this here. So you see it's 318. I want you to think, okay, if my new novel was 80 pages, how long would it take? Can you just do it mentally in your head? If it was 80 pages and I could read 40 pages in an hour, if it was 80 pages, 1 hour is going to be 40. Right? So here's 40 pages. And the second hour is going to be another 40 pages. So that would be all. If this was 80 pages, that would be 2 hours, right? 1 hour and 1 hour, add them together. This would be 2 hours. Okay. So what did you do? So think about what we just did. So there's a rate that's in here. 40 pages to 1 hour, 40 pages per hour. That's what we're doing here. If it was 2 hours, notice that the hours cancel, and 2 times 40 is 80 pages. Do you see that? Okay, so when we have goofy numbers like this, make the numbers really simple so you understand, and then just mentally do it, and then you can back out, how did I know that again? How did I do that? Okay, so we're going to put the problem back the way it was. Here, I'll go like this. There we go. Okay, so we have our rate. It's 40 pages in 1 hour. Okay, that's the rate we can read at. Then what we're going to say is, okay, 318 pages. So I have 318 pages. I can read 40 an hour. So in 1 hour, I can read 40 pages. Do you see how the pages are going to cancel, the little p? Okay, so those cancel, and I'm only left with time on top. So that tells me, here, I'll do it here, 318 divided by 40. Okay, so this is pages per hour. My answer is going to be, now you grab your calculator. You see how this is like the very last part? And then just do the simple division, 7.95 hours. Okay. So again, you want to break it down, make the numbers a little bit simpler, because the numbers are going to start to get harder now that you're a little bit older and further along in your math journey. So just make the numbers easier. Do it mentally because you've got common sense about stuff. And then kind of figure out, okay, wait, how did I do that? Oh, yeah, okay. And then you can take this rate to be either 40 pages an hour, or in 1 hour it's 40 pages, either one. So we took the reciprocal here, we flipped it over. Okay, so the units would cancel, and we'd be left with hours on top. And that's how you know to divide or multiply the numbers. All right, how many people are feeling like, I'm not sure about this problem? Or, okay, give me a smile if you're like, oh, that totally made sense. Totally made sense. Oh, good, lots of smiles. Good. So what this looks like on a timeline, I get that book in my hot little paws at time 0. In 1 hour, that's 40 pages. In 2 hours, that's 80 pages. In 3 hours, it's 120 pages, right? Because we're just adding 40 each time. And in 4 hours, 160 pages, da, da, da. So we're shortcutting this, and we're saying, okay, when we're over here at just about 8, almost 8, we will have read that many pages, a little bit more than 318. So the other thing is, once you know the speed that you can read, you can set up a proportion. Let me show you something. This is really cool. So I can draw myself a graph that says time is here and hours are here. 1 hour, 2 hours, 3 hours, 4 hours, 5 hours, okay, onward. And if I know my rate, this is a number of pages. If I know this is 40, 80, 120, if I can, so I have 1 and 40, this is my first. In 1 hour, I will read 40 pages. In 2 hours, I will read 80 pages, just like on that number line. 3 hours, I will read 120 pages, just like that. So I will start to get a line, and this is a relationship between number of pages I can read and time, or this could be miles you can go and gas in your car. It could be anything. So if I want to know, okay, what's like 100, I can go over here. 100 pages will take me, and then I could just read it right off the graph between 2 and 3, so 2.5. So that will allow me to set up the proportion. So the rate is this line. This is my 40 pages in an hour. So that's another way to think about what we had just done on the other page, right? So as I said, there's going to be multiple ways to do these problems. Yeah. Okay, how many of you were in second grade at one point? Yeah, like all of you, right? Okay, in second grade, true story, second graders know 6,000 words in their vocabulary. That's how many they have. By the time you're in sixth grade, take a wild guess. How many words do you think you know? Hopefully more. Yes. Yeah, like an order of magnitude more. You guys know about 50,000 words. Good going, right? How many words are you going to know by eighth grade? I want to know. Remember that graph I just drew? So what we're going to do is we're going to use this relationship here to make a line on the graph, and then we're going to extend that out and say, okay, for eighth grade, this is what I would expect. Okay, you want to see how we do that? Okay, so the first thing we have to do is we have to say, okay, how many words did you jump? How many words did you learn between second and sixth grade? How many did you add to your vocabulary to get to be from a second grader to a sixth grader? That's our first step. So what we're going to do is we're going to say, okay, sixth grader knows 50,000. Yes, this is accurate. Yes. Okay, and we're going to subtract that to find how much did I add to get to sixth grade. Yeah. Okay, so that's 44,000. So between second and sixth grade, you learned that many more words. Okay, you with me so far? Okay, how many years are there between second and sixth grade? 6 minus 2 is 4. Yeah, that's an easy one, right? So in 4 years, you learned 44,000 words. Good job. So what does that look like as a ratio? So the ratio is going to be, the rate is going to look like you learned 44,000 words in 4 years. Stop me if this isn't making sense so far. It's okay if you don't know how to do this yet. That's why you're in class. Okay, so you learned, yes, this is proportionality. Very good. So in 4 years, between second and sixth, you went from 6,000 to 50,000, and this is a way in math we have of writing that down. Okay, I didn't lose anybody yet, right? So can you tell me how many words per year that is? Divide 44,000 by 4. Can you do it in your head? What's 44 divided by 4? Yeah, it's 11. And then add the zeros. Words per year. So in 1 year, 11,000. So that's third grade. Then you'd add another 11,000 and another 11,000. So it's not as linear as that, but we're just we're trying to make a relationship here. Good. Okay, so what does that mean? That means that in sixth grade, you're at 50,000. Seventh grade, you're at 50,000 plus how much? 11,000. And in eighth grade, okay, so this is 50 plus 11. Here, just do it like this. 50 plus 11 is 61. And in eighth grade, you're 61,000. How much do we add to it? 11,000. I know, you're busy, aren't you? 10 plus 61 is 71. Then add one more. So you're at 72,000. Okay. I didn't lose anybody yet, right? No? Okay. So let's draw this on a graph so it makes more sense. Okay. So I'm going to take these same numbers and let's put it on a graph so you can see it. Okay, same thing. So on a graph, this is your grade, like 4th, 5th, 6th. Okay, so I'm going to start second grade here, 3rd, 4, 5, 6, 7, 8. Okay, and I had some data points. This is the number of words. Number of words. Okay, so in second grade, do you remember how much it was? Yeah, it was 6,000 words. That's something I gave you. Okay, so that's there. And then we skipped ahead to sixth grade, and you were at 50,000. for 6th grade. So we go up and we go over. So there's 6th grade. So now what we do is we take a ruler and we say, okay, if this rate continues, okay, and I go to 7th, I can go here, and I can come over. And if I did my increments right, this was our 61,000. Okay, this is our 61, and 8 is here, and this is our 72. So the further down we go, the more our words go up. You've seen how it increase, increase, increase? Good. So you can kind of back it up here and say 4th grade, what would that be? Okay, and so then you could read it off if I had more tick marks on this side. You want to see the other page? There, like this one? All right, so how is that, I should ask, how are you doing with this? Do you have to draw a graph every single time? No, actually, that's usually a less efficient way. We draw graphs so we can start to think about the problem, so it starts to make sense what we're doing. Okay, so how many of you would love to do this without all this extra work? You just want like one equation, you can throw it in there, and it'll work every time. Wouldn't that be nice? Okay, let me show you how you can do this. How many of you like cats? Okay, I need my cat team and my dog team. Where are my cats? Give me a thumbs up for cats. Okay, if you're on my cat team. Good. All right, dog team, where are you? Okay, we'll just use the proportion in class. You like both, oh boy. You're the one who's gonna mess up my proportion, huh? Okay, so what we're gonna do is a percent proportion.